And action. Hi, hello. Nice to have you here for this webinar, the first of 2023, about insight. There is this first part where I'm going to say hello, and then there is a record part where there is actually the presentation and the demo about insight. It lasts about half an hour, and after that, there will be the question and answer sessions, where I will be happy to answer your questions. So the thing is that during the recording, there will be 3 polls. So we will be happy if you can feed there with like answering the polls questions for statistical purpose. And also you could write during the recording, you could write as well your question. And by the way, that's the only way that you can ask questions. So please ask your questions. And then at the end, I will read them and I will answer to them. So thanks for attending. We are really glad to have you here with us for this webinar. So now I leave the room for the recording. See you in about half an hour. Welcome. Welcome to this first webinar of 2023. We are really happy to be back with you here. And this first webinar will be dedicated to our software Insight, our processing software. So basically, we will show you how to browse hyperspectral imaging data, how to create a model, and also we will invite you to this journey so that you understand better like what can be done with our software. Before to go deep into these topics, you recognize me, you know me. I am Mathieu Marmion. You know I'm working since almost 12 years at Specim as a lead application specialist. I'm really happy to host you here for this webinar. So first we will go through the agenda. So as a first, we will go through the presentation of Specim to give you an introduction about who we are. I think you know who we are, but still it's always good to remind you. We're not going to explain what is hyperspectral imaging because you already know these topics and we spoke about it in every webinar. So basically there is no need to explain it again. That's why we would jump directly into the topic of Specim 1. What is Specim 1? To give you a context about Insight. Then we will tell what is Insight. What is this processing software? Talking is nice, but showing is actually better. So then we're going to have a demo with my laptop, which is just over there. There I will show you how to go through the data, how to browse the data, how to make some data exploration, and how to build a model, qualitative but also quantitative. And finally, some time will be reserved for you, for your questions, and we will try to answer all of them. But then let's first jump to the presentation of Specim. So as you know, we have been created in 1995, and it's like 23 years ago this year. And since the beginning, we have delivered about 9,000 devices all around the world. Since 2020, we are part of Konica Minolta. We are really happy about it. It's a big family, and we are proud to be part of this big family. We are about 90 people, and as you can see, from the map, we start to be spread all around the world. We have some offices in the United States, also in Europe, where I am now in Finland, but there is also one in Germany and another one in Spain. And we have an office also in Asia. We have a distribution, a distribution of network with distributor all around the world who can help you as well to purchase our devices and where you can also learn more about our technology. So first about what is Specim 1, to give you a content, to give you context, for Insight. So Insight is part of a platform. This platform, Specim 1, which includes a cube where you can acquire data, and also the data could be processed in real time. There is Insight, which is a processing software, and those combined with FX camera allow you to make like this, to make the integration of hyperspectral imaging easy for your industrial environment. So Specim 1, it helps you to classify different types of material. This is actually where it started from, you know, for recycling industry, for example, like contaminant detection. The idea also is that you can make quantitative analysis nowadays, so you can measure, for example, moisture in different types of samples. You can apply the model for inline data analysis, so you can use it for offline but also inline for real-time processing. Because of the nice user interface, graphical user interface, you can use the software without in-depth knowledge about chemometrics and about hyperspectral imaging. Because of this platform, it helps you also to integrate the technology really quickly within your industrial environment, meaning that it reduces the time to go to the market with the technology. And also, because of the technology, the hyperspectral imaging technology, you can have high flexibility and you can use this in a large panel of application. So Specim One could be integrated that way within your environment. So imagine you have the cube, you remember, this is the thing looking a bit like a shoebox with a GPU inside. The camera is connected to it. You can acquire some data. Once you have acquired the data, they can be then loaded into your local platform where INSIGHT is actually installed. In my case, it's on my laptop. There you can look at the data, you can build a model, quantitative or qualitative. Once you are happy with your model, it can then be converted into an app, an application that you can load again in the cube, and then the data can be acquired from the camera, processed with the app in real time, so that actually you get, as the output of the cube, not only spectra, but also classes. And here we have different type of protocols, which are like compatible, for example, with GigiVision. So this is for the output of the cube, and then you can also control PLCs, for example, if you need to have automates. So what is Specim INSIGHT? Specim INSIGHT, basically, this is the software. This is a software that we have developed at Specim. It is robust and it is fast to build qualitative and quantitative model to support also multi-ROI, because you remember that one feature of the FX camera is to have the multispectral ROI, meaning that if you're not interested in looking at the full spectral range of the data, you can cut them, and here the camera can be faster and also the processing can be faster. It also supports for all Specim dataset format of the camera. It also works, meaning with not only FX camera, it works with the Sphere camera, for example. It works as well with the IQ camera. So the INSIGHT software could be used offline for also dataset acquired for those cameras. It is supported by Windows 10 operative system. So we are working, of course, in our roadmap to have it compatible for the next release version of Windows, but at the date of today, it is Windows 10. And then when data are acquired, with our acquisition software at Specim, they are saved in the NV format. So it means that our processing software INSIGHT is also able to open those data. Of course, when you have a software, it needs to have some system requirement, and here you can see them. This is part actually of our manual. You have the minimum requirements, so I'm not going to go through. I mean, you can see them here on this slide. And there is also the recommended PC requirement. Of course, if you have a more powerful computer, it's always better, especially when you speak about data processing. Then, how Specim works. We are going to go to a journey now through INSIGHT. I'm going to show you how to make some data exploration, our browsing, the viewing, and then also classification model with a quantitative and qualitative data analysis. So please now, let's look at what we have on the computer on my screen. So here you can see the software. The software has actually different type of sub-windows which are here. There is a browser, the explore, the train, and then the app. Of course, here there are some different options as well where you can actually choose which type of backhand you want to have in your computer. Now, because I will be showing to you some really heavy data set in terms of memory, I prefer to use a CPU behind. So first about the Explore. Here you can choose which data you want to look at. Those data which are here, they are actually something which is public, so there is nothing confidential. So I'm really happy to share this screen with you. And those data sets are those that I have acquired with the FX17. And here for the demonstration, I will go through some plastics. So for example, this one where I have 3 data sets of plastics. They're actually the same samples from each of the other, but just arranged in different manner. So here, if I click on one data set in this browsing interface, you can first see the data set opening here with here some metadata. You have the possibility as well to crop it and to bin it. So you can make like this a spatial cropping if you want like this. You can also make a spectral cropping like this. And then you can choose also the binning configuration just here. You have the possibility to do that. And you have also the possibility to rename your dataset or to erase it from the disk. If I click twice on it, then I move to the exploring view, and there you have the possibility, like this, to move into your dataset down to the pixel level. And here you can see, you can move also this pointer, and you can see the spectrum at each of the pixels. You don't need to have only one spectra to be visualized, but you can have several like this. If you are not interested actually by looking like this point spectra, you can have different selection. So for instance, here you have all those selective tools. The first one, the most easy to use, is of course the rectangle. I can make like this several rectangle selection, and again the spectrum could be visualized here. So here you can see we have three types of plastics. I have to be honest, I don't remember which one was which one. I recall we had some P, some PVC, and some PET. And there you have also the possibility to move the visualization band like this at different places to see your data at different RGB values. Sometimes you can have samples which are rather dark, so you have the possibility like this to scale the image for each of the bands, so actually you can improve the visualization. In the previous dataset, in the dataset we are looking now, there is no need, but there is this possibility. If you don't want to look at the false RGB, you can see here a single band as well, and you can travel, I would say like this, through your data. But let's go back here to the false RGB, and here we are. A tool which is interesting as well at that level is that you can make a principal component analysis. So first I will remove those selections, and you can make a large one, or you can make the principal component analysis over the full data set. So now I will do it over the full data set with the possibility to select how many bands you want to have. If you want to have a background removal, so basically it means like it will compute an average value for each spectra, and everything which is below this value will be considered as background. So here in this example, it will consider that everything having a reflectance below 7% will be considered as background and will be removed from the PCA. That works really well when you have dark background, for example, like here. You can change the value, for example, you can put here 10%, that's one way. You also have the possibility to apply some pre-processing already at this stage, like Savitsky-Golay, with a filter with derivative order and polynomial order. About the preprocessor, I will speak about it also later when we are going to train the model. We have a technical note explaining the point of those preprocessors and how they enhance the feature you want to see in your data. So once you have selected or adjusted the parameter you want to have for your principal component analysis, you can just run it and we will see the results. So now it is computing, and here we have actually the results of the principal component analysis. So already from here, you could see based on the false RGB here that you have indeed three types of plastics. And we can see, looking here at the principal component analysis, that you have in fact three clusters of points. Here you can make some selection, like this, block, and that corresponds actually to the upper samples. Just to explain quickly what it is, this is true, I'm already showing that without explaining what it is. Here, you know, when you make a principal component analysis, basically you transform your multivariate data set into another multivariate data set, but this time on the first component you have most of the spectral variances. Then on the second band you have the second most variances, but then the second band is orthogonal to the first principal component. Actually it's a principal component, it's not a band. And here it is one way to look at your data again. You can look at them projected with the principal component 1 versus the principal component 2. And then by plotting every pixel into this diagram, you can actually see some clusters. And here you can see the first one. Then here we can see another cluster of points, which correspond to the sample at the bottom. And here you understand that the last cluster of points correspond to the samples which are at the middle. So already from here, you understand that with the principal component analysis, you can have an idea like if you have some different type of material within your data set, and here already you have the possibility like this to try to understand if you have the possibility to sort them from each other. Already with the principal component analysis, it gives you a clue. Yes, I will be able to sort those material from each other. You can also change, for some reason, the band you want to have your scatter plot. So here it is band 1 versus band 2, but you can have, for example, different type of bands. So here I could project the data, band 3 versus band 2, and things like this. Also, for the red, green, blue, for the false RGB, you can allocate different bands than those which were allocated by default, 1, 2, 3. So here it could be 4, 2, 3, and things like this. So you can really make some exploration of your data. I just would like to highlight here that the principal component analysis is an unsupervised classification method. So it means that when someone is giving you a sample and then they ask, please find if you find some defect in there without knowing where they are in advance, basically this tool can highlight where is what. So already here you can see that with the exploring view, you have the possibility like this to already look in your data, look at the spectra, to also make a principal component analysis like this to highlight where you have differences. But based on that, you cannot really create a model. When you want to create a model, you need to go back to the browser interface and then right-click, and then you add this data set as a training. And then here you go to the train interface, train page, where here you have the possibility to build actually your model. So we have the data set, you recognize it, and here you have the possibility to teach what is what in a statistical manner. So first, we will make a qualitative data analysis, meaning sorting A from B from C. In the next step, I will show you how to make a quantitative data analysis when you want to measure, for example, moisture in cotton patches. But first here, the qualitative data analysis. We'll make 3 selections, like this, corresponding to the 3 materials we are having. We are telling that here we are going to have 3 classes. You can change the color as you wish. For example, if you don't want to have something blue here, you can choose whatever you want. But I think blue in that respect is pretty good. Now, you can rename, of course, your data. So here's going to be the plastics A. Here there is also the plastics B. And finally, the plastics C. And then there is a background. We will say that everything which is between 0 and 7% as average spectra will be considered as a background. It is exactly the same as I was explaining previously with the exploring view with the principal component analysis. Notice that here you have the possibility to set a minimum and a max. So that means that if you have a black belt, that works really well. But if you have a bright one, that works as well. So you can say everything between 80%, for example, and 100% reflectance could be considered as a background. As you can see, there is something which is called unclassified here. I will explain in the next step what it is. So here, for each of the selection, we need to tell what is what. Here, we select the algorithm. We have PLS, PLSDA, so the one dedicated for qualitative data analysis, it is the PLSDA. At the date of today, we have only this algorithm, but we are working in improving that, in having more and more algorithm available for the user in the next releases. So this one, and then we can just test. And here already you can see that the model is already pretty good. It's not perfect. there is an edge effect, like here, for example, you see there are pixels which are not really well classified. Here neither, and here neither. But then we may think how to improve these kind of things. And to do that, we have the possibility to add some pre-processing. And here you have actually the library of preprocessors what we have already implemented within this software. With those preprocessors, you can really improve the sorting capability and the robustness of your model, and we can try different ones. So typically, for plastic analysis, I'm using Savitzky-Golay SNV transform. Here, I will take those. You can choose the order of those. You can adjust some parameters like here, and then we can try again, and we see what we get. Here we can see it's slightly better, but it's not perfect. Here before we had a pixel which was wrongly sorted. Now this one is actually correctly sorted. How was it previously? Here we had a lot of edge pixels wrongly classified. Here again, they are better. Only here still the edge is not perfect. We can think about different strategy to improve that. One way to do is, for example, to make a multi-ROI, meaning that here you don't want to measure, to take into account the full spectral range of the camera into your model, but you can choose only a part of it. And to do that, you can make some selection like this. You can have several. You don't need to have only one, but you can have several if you wish. So here we're looking at the spectra. I think it would be relevant to have only one, so I will remove that one. And I will also remove that one. And here, I will go until here. And let's see what it does. Now we are careful that it takes wavelength 1, wavelength 1. Then we can test. And here we have a perfect model. Here you can see we don't have edge effect anymore. So okay, we have only one small pixel here, but just to show you that actually I'm not photoshopping anything, it is really real. But here you can really understand that you have possibility like this to improve your model. Also, one thing which is always interesting to look at is how the spectra are transformed by the pre-processing. You can see it from here. Pre-processing show the pre-processed spectra, and this is how they look like after then the Savitzky-Golay smoothing and also the SNV. Okay, so here it was just to show you how to make a qualitative model. Once you're happy with your model, you can just convert it into an app, which would then go here, that you can then load to the cube. That was part of a previous webinar we were having. Now I don't have the cube which is connected, so I'm not going to focus into that. Another thing is that you can also check the accuracy of your model. You can make, for example, like this, a selection. You don't use it as a train, but you use it as a validation. And here you say what you expect to find. So normally I expect to find plastic A. On purpose, I made this selection too wide, not only on plastic A, it takes into account some background, but just really to show you what happens. When I do that, it will compute a confusion matrix, and it will tell you how many pixels are correctly classified and how many are wrongly classified. So here you expected A plastics. So you have predicted 1,928 some pixels as plastic A, so they are correct, that's why they are in green. But then in the selection there were 2,166 pixels which were actually sorted as a background, which at the end is correct because the selection is over the background as well. But just to show you that here you can compute confusion matrix and you can really evaluate the relevance of your model. You remember when I was making the class identification, as this is the class manager, I told you that there is something called unclassified, and I would like to come back to it. Here, in this model that I built it first, here, and we evaluated how accurate it was, for every pixel there is a possibility to be sorted as plastic A, B, and C. And every pixel will be sorted either in A, B, and C. But you can also give the possibility that it is not A, B, or C. So here you can actually use the unclassified. So basically you can set a threshold for each of the classes, which is between 0 and 1. 0 being really conservative, 1 being really open. So that means that statistically speaking, everything which is close to be A will be sorted as A, close to be B will be sorted as B, close to be C will be sorted as C. But if you have something, a pixel, which is neither close to be A, B, C within the thresholds that you are putting in there, then you give the possibility to be unclassified. So here I've been putting all of those with the same value, but you have the possibility as well to change the sensitivity here. Then we can try our model again with this feature, and here you can see some of the pixels appeared in gray here because then they are a bit too far away from being A, B, and C, and you see those were the problematic ones when we gave the possibility, when we did not apply, the pre-processing. And finally, the last thing I would like to show here about this qualitative model is that you can have several data sets as well in the training, so you don't need to train only on a single data set, but you can also apply a model like this on several data sets. So you can make several selections to train, or you can simply just apply this model in here. So first it applies to that one, which was a training one, and then it will apply also to this one. Okay, so here that was how to make a qualitative model. There are some more features. This demo is not really a tutorial, so if you want to have more information, I mean, like, you may want to look at the manual, but this is not the point of this demo. The next step is to show you how to actually build a qualitative model and how to build a qualitative model. So first, I will take some other data set. I will clean the model here. Yes, I want to remove all the model. And to make a quantitative model, I want to open a data set which is here. When I was actually measuring a cotton patch, completely wet, and then I let it dry during like a certain time, during about 4 or 5 hours, and then I was measuring every 4 minutes with FX17 this cotton patch. And then you can see that over the time it has been drying. You can already see it here from the files RGB that the color is changing like gradually over the time. And remember, like between each measurement there are actually 4 minutes. With our software you have the possibility to make some mosaicing. So for instance, you can open 2 datasets or several datasets at the same time into the exploring view. And we still have here the plastic, so kill it like this. We don't need the PCA anymore. And here you can see you have like 2 datasets which are here. You can make some selection, remove those ones. I will make rectangle selection, block, forgot, like this. And then a second one, like this. And already like this, you can select those. And then you have the possibility like this to make a mosaic. So you can have like this selections that you can reduce somehow the data sets that you are having if you don't want to keep the full things, because here, as you can see, you have mostly background. So if you want to make a data set including only those, you have this possibility. Well, I'm not going to show you here into details, but this is what I have done to create this mosaic data set, which is just here, and then we will go directly into the training. Here. Oh, it did not take the one I want, sorry, I still have those selected. I say this one only, and then add to train. It's a big data set, so that's why it takes a bit of time. I think it's about 7 gigs to the best of my memory. So here we go. Here we have the data set, and I will make like this a quantitative analysis of it, of the moisture. So the way to do it is that first you need to make a sorting model, a qualitative model, meaning sorting the sample from the background. So here what I will do is that we'll first make a selection. This time a circular selection is more clever. Over here like this, one of the sample, and then over the background. Then here I will make a hard sorting. Yes, it remembers those ones. Toc, toc, like this. So the first one, actually, the name is going to be called cotton. The second one is going to be called background, like this. And here I'm going to have it in black, like this. I don't need to have that one anymore. I do like this. Then this one, it is what I had on the previews. I remove it. Here we are. It still remembers the preprocessor from the previous model. I don't need to have those anymore. Like this. And here we just need to tell what is what. So here we have the cotton, here we have the background. And then we test. And then now it is just separating the cotton patch actually from the rest. And it is exactly on the cotton patch that I want to build afterwards the quantitative model. So here it's going through like this. So now I am actually ready to build now the quantitative analysis. So first I will select a relevant algorithm. It's going to be a PLS, partial least square. Then here I just tell that I'm going to have one variable that we will call, for example, drying. That is the name of the variable. Like this. It's going to be double numbers, and it's going to range between 0 and actually about, let's say it was more than 60 data set acquired every 4 minutes. So let's put 270. And here's a allowed error. I will explain you afterward what it is, but here I put 2. So, and as a color map, I like to use magma. So here I close, and then I will make some selection everywhere. And for each of those, I will tell what is the moisture level. So here it takes a bit of time, and Harry, of course, will make. So here you can see I have made selection for each of the patches, and nicely the average spectrum is actually changing over the time. You can see that the drying actually affected the average spectrum, which is quite interesting and nice, because this is based on that the quantitative model will be based. And then for each of the selection, we need to actually tell what is the drying level. So here it was 0 minutes. This one was the background, so I will not include it into the quantification model. But the next one I will, as it was 4 minutes, and so on. So I will fill those. All right, now we have filled for each of the selection a value, like this, a drying time, and then we can test what we get now. So here basically the model is applied. So first, a qualitative model somehow to separate the sample from the rest, and then this PLS regression will then be applied on those only. So here we can see the model which is then applied. And as you can see, for each of the cotton patch, we are having here regression values, like a heat map. And here you can see for each of the selection, now we have like this, for each of the samples, the cotton patch, we are having like this, the values. Of course, if you don't want to see the selection, you can just select like this, and you can remove them, or just by selecting all of them and so on. You can just remove all the selection. One thing which is interesting to do is actually also not to have everything selected as training, but then you can compute as well a R-square by selecting, for example, half of the selection as training and half as validations. For example, this one will be still selected as training, and this one could be as a validation. So I will select every second one like this. All right, so here we have selected every second selection as a validation one. A new model will be built, meaning training the model only in half of the selections and those selected as training. And then the accuracy of the model will then be computed on the validation ones. So here we can see the model applied everywhere. Okay, and here's the finalizing. So basically we will have the possibility to see the R-square of this model. Here we go. So here you can see what is R-square, is 0.98, which is actually really good. Here you can see the selection, the average selection accuracy. So basically, you remember that when I was defining here the variable, I was putting here a nullard error. So that means that every time we made a selection like this and the model is applied, of course, for each pixel, a quantitative value will be given. And that means here it tells you, for example, if here it was, I don't remember what was this value, but if it was, for example, 20 minutes of trying, or let's say half an hour, even more, but if it was a certain value, then when you make a model, it checks for each pixel if you are within plus or minus 2, which is a nullard error in here. So it's not really for building the model, but just for you to check how within a training selection the accuracy is. But anyway, here we are having a really good model, 0.98. And the last graph I would like to show you about this quantitative regression is when you make either a full report or then you can look at the regression graph, the well-known actual versus prediction. And here you can see how actually the model behave and give good results. So you know you need to have all your points following this line, actual versus prediction, and you can see it is really close from it. So that was it for this demonstration. You see when you build a model like this, which is good, then you convert it into an application. And I hope this demonstration already gave you a hint of what you can do with Insight. So we had the demonstration. I hope it was interesting to you. Before to conclude and to go to the Q&A session, I would like to give you back the context in which actually Insight is. So as you know, we help you to solve your problem with hyperspectral imaging and we help you to build successfully your project. So just to give you a reminder, so about the context, so basically you have Insight, which is part of the SpecimOne platform, which is here to build a model which can then be converted into an app to convert spectra in real time into classes or quantitative value. The idea of Specim is to make spectral imaging easy, so we do our best for that. So now we are ready to answer your question. Keep in mind, by the way, that we can always arrange demo and you can ask for a quote. So here you can go to specim.com. Please, now the room is yours and I will answer your questions. I'm back. So, glad to be back again. So I hope you like the demonstration like this for qualitative and quantitative data analysis. So now we are ready. I am ready to answer your questions and I see that we got already quite many. By the way, I would like to thank you for answering the polls, like that Harry was actually posting, and we were really, really interested to see your answer over there. So that's really, really cool. And then, okay, I'm going through the questions that you sent. If you have more questions, please write them in the chatter, and then Harry will post them as questions. So I will go through, and I will do my best to answer. If I'm not able to answer, then I will try to answer later. So the first one, can it be supported by Unix or Linux? No. As of the date of today, the Insight software is supported only on Windows 10 and 11. So those are the only platform for it so far. Is there any problem sorting black color plastics? You will need to use the FX50. If you have a plastic which is colored not black, you could use the FX17, which is between 900 and 1700 nanometers. This camera is used by many of our customers for online sorting like this. If they are black or whatever, by the way, then you need to use the FX50, which is between 2.7 and 5.3 micrometers. If you go to our website, in the blog part, there is an article about it, and you could see that you could sort PE, PP, PS, ABS, PCABS, regardless the coloration, even if they are black. Do you have experience in scanning eggs? Actually, yes. The idea is that we had 2 or 3 customers, I don't remember exactly the amount, but we had some customers who were interested to see if there was an embryo inside the egg or not, and if it was a male or if it was a female. So it was possible to use, for example, an FX10 camera in a transmission mode. So basically you have the egg which is here, the illumination behind, and the FX10 over here. And then with a quite intense illumination, especially on white eggs, you could detect if it has been fertilized or not. So yes, we have some experience. But I have to say this is not the application where we have most of the experience. It would be excellent to see an example of classification, and all this again an unstructured background, such as with phenotyping with aerial data. Well, first of all, the primary role of INSIGHT, when it has been developed, it was more like for not aerial application, but it was more like for sorting application, like at the top of a conveyor belt or at the top of a scanner. Having said that, we have been using it as well with some plant, with some tomatoes plants, with some pelargonium leaves as well. And here's the idea, especially in the Explore, there is a possibility to have a calculator, so you can add a lot of different type of ratio and things like this, and it has been used for that. About the background, when it is not structures, as you mentioned, we have customer and I have myself made some analysis, but you just need to define the background as a separate class. Things like this, you can do it as well, but yeah, that's how it is done. I have processed as well some airborne data with INSIGHT. It can go through as well, so it can be done, but maybe not with the same tool as I was showing, like with the background removal. When you have a certain level, you put as a minimum everything which is below this minimum, then below this maximum, then it is considered as a background, but there are ways to do. What is the smallest sample size that can be measured? It depends on your pixel size, and I'm used to say that it's about, to be on the safe side, the smallest pieces of materials that can be sorted, it is about 3 times the pixel size. So remember, all our cameras are line scan devices, so it means that they measure along a line, and each individual pixel, they have independent spectral information. So basically, you take the field of view of the camera and you divide by the amount of pixels. For the FX10, it's 1024. For the FX17 and the FX50, it is 640. So you divide this field of view by this amount of pixel, and it gives you the pixel size. And I'm used to say that it's about 3 times the pixel size of the smallest object you can sort. So depending on the measurement distance and the front objective that you are using, you can have different type of field of view and then different type of pixel size. Okay, can data and model be exported directly from INSIGHT? When you make a model in INSIGHT, it has a certain format which is compatible with INSIGHT only. I can say that it is Python based, but I have to say that I'm not sure that it's possible to extract from the model something that you as a Lambda user, you can then use it. The idea of having the model made by INSIGHT like this is not necessarily that you can open it in something else. Remember that INSIGHT is part of a context, it's part of SpecimOne, where actually the point is that the model could be also integrated or converted into an app which can then be loaded into the cube for real-time analysis. So here we do not necessarily give the possibility to open too much a model. Having said that, the point of making the model in INSIGHT is not necessarily that you can input it in something else afterwards. Do you need to use a Specum camera with the software? Well, first of all, the software INSIGHT is not connected to the camera. It's not an acquisition software. It's only a processing software. So the input here, this is a data set. Then what is important, it is the format of the data set. And here, INSIGHT is compatible with dataset from the NV format. Data type number, I think it's 12 when it is unsigned integer and 4 when it is in floating, BIL interleaves. So it is compatible with this format. So then if you have a dataset which is in this format, you can open it with INSIGHT. If it is a dataset which is not in this format, you cannot open it in INSIGHT. This is here what you have to keep in mind. But if you have a Specim camera and a Specim acquisition software, all the data you have acquired, either with IQ, either with FX, with Lumo scanner, you will not have any problem, you will be able to open. And without being FX, by the way, it could be also like the Sphere camera. What are the main benefits of Specim INSIGHT compared to, for example, Predictable Breeze or other similar software tools? Well, different softwares, they may have different type of algorithm, not necessarily the same. The user interface is different, so I have to say INSIGHT is quite easy to use. The graphical interface, I like it, or maybe because I'm used to it as well. But I have tried, for example, Mira, I have tried the one from Perception Studio, so Perception Spark, which was Perception Studio, LoxFlux, different type of. So then it's a question of taste. Do you prefer one user interface compared to another one? Some softwares are more like a black box, meaning that you just input the selection and then the model is built on its own and you do not necessarily control what you have. In INSIGHT, you can have the control. As you could see, I could select the band, I could select the preprocessors, the algorithm as well. So as a whole, I would say the software on its own, it's a matter of taste. But then what is also interesting is that you can put INSIGHT, as I say, within the context of being the Specim one, so you can make the applications and load it in the cube. And then the cube actually here is optimized. So basically when you make an application with INSIGHT, you load it in the cube, then you can optimize what is the latency, especially for online analysis. So the latency, it is the time between the acquisition of the data and the sorting of the data. So meaning like if it is A, B, C, or if it is 10% of moisture or something else. So here we have the possibility to interface pretty nicely INSIGHT with the cube as a whole package where we have a full control of the latency and its variability. So I would say this is quite a plus, because typically the other ones, like the one you mentioned, Breeze, is not necessarily connected like this with a processing platform which is optimized for this type of analysis. Well, and another thing, by the way, we have is INSIGHT, and I did not show it here, but we have the possibility to make some color analysis which you do not necessarily have in the other software. Can the cotton humidity be adopted to check humidity of wheat flour, of maize flour? The way I have done it with the cotton could give you some idea how to do it, for example, with the wheat or with the flour. So it means that you need to have reference samples where you know the humidity level, and then you can see how the spectrum is affected. I will not say you do it directly with the cotton, because the base spectrum of the cotton is quite different from the base spectrum of the wheat and the flour. So here you cannot choose a model purely based on cotton only if you want to monitor the humidity of something else. So you need to have this something else. Of course, you can restrain your spectral range to the water absorption. As you saw, it was around 14-30 nanometers. But still, you need to know what is the base spectrum, where you are starting from or where you want to arrive. It depends if you are drying or if you are like wetting. But the idea is the same, but don't use a model made of cotton exactly to measure like this the moisture level of flour and the wheat. Can I use this software for SpecimINSIGHT data? Yes, you can do that. It works really well. Having said that, once you make an application with Specim INSIGHT, you cannot load it inside the cube as you could do with IQ Studio. So you know with IQ Studio, you can make an application that you can then load into the IQ. You cannot do that with INSIGHT, but you can process the data, you can look at them, and so on. Can one implement their own model? Can you load data set with labels instead of manually setting them in the tool? Can you implement your own model? Not at the date of today, but I have to say this is somewhere in our roadmap we are considering giving the possibility to users, those who already have made a model, to implement it then into INSIGHT. This is something we are discussing. It's not open yet. And then the next question, can you load dataset with labels instead of manually setting them in the tool? Not yet. You have to set manually. Is it possible to try your software without buying your hardware? Yes, that's a possibility. You have to contact our sales team. If you are a competitor, we may think, by the way, hello, our competitor. We know you are here. So it's nice to have you here, by the way. But yeah, there are possibilities that we can agree. You can agree with our sales team, so please contact us. What is the best process to distinguish bruises on apple? Well, first of all, I will consider the camera. So here, the camera I will use will be more like an NIR camera because you need to see through the skin. You know that typically hyperspectral cameras, they are like surface measurement methods, so you can see only at the surface, but there is a penetration depth. And the more you go toward longer wavelengths, the more you can see through. So you can see that with painting, for example, but also with the fruit. So here I have seen images, for example, of apples taken with a sphere camera. You could see nicely the bruise. The idea is that when you have a bruise, the water is not having the same structure in the cells that when you don't have a bruise. And here I will do a PLSDA because at the end of the day, this is a qualitative analysis. Do you have a bruise or you don't have a bruise? So I will use an FX17 with a PLSD algorithm, and I think with INSIGHT it could work actually. I haven't tried, but I don't see why it will not. So did I get it right? The model can provide information about how big portion of the pixel in the image belong to a certain class. Yes, so basically what it tells is like you have an object, and then for each pixel of the object, you know to which class it relates. Remember that our classification is pixel-based, is not object-based. So within an object, you can have many pixels, and each of them are sorted as something. So yes, indeed, you can get this kind of information with our devices. Would love to see the camera capturing via drone for phenology characterization. Well, we have here the AFX family. So basically, this is the same as having an FX camera, which is, so we have the two FX10 or FX17. And we have also the airborne, how can I say, airborne like option for those, let's say it that way. So you have the camera attached with the GNSS IMU unit, a microcomputer, and also a sensor control board, all of that. So if you go to our website, there is something called AFX, like airborne FX, and there you can see our model. And those could be used for phenotyping or like precision agriculture, this type of application. So we have the one between 400 and 1000 and the one between 900 and 1700 nanometers. What are the limitations in terms of dataset size, number of samples and number of spectral bands? What I would say, it depends mostly on your computer, basically. On your computer, when you turn on INSIGHT, you can choose. Either you want to use as a back end the GPU, and typically if you want to process the data with the GPU, you are limited to about 3 gigabytes of data, or you can choose as a back end to use the CPU, and then you use more the RAM of your computer. And here, for example, of my computer, I use my laptop, I have 64 gigabytes of RAM. And as you could see, for example, with the Cotton, I did not have any issue. I was able to load them without any problem. So I would say it depends on your computer, actually, these kind of things, but not really on the software. The software is able to handle large amount of data. And then the number of samples and number of spectral bands, well, again, it more depends on your computer and not really on the data itself. If the image is taken from a different camera and has a different range, say up to 2500 nanometers, can INSIGHT work with that? Yes, I have been using INSIGHT with like a thermal camera, with a sphere camera. For INSIGHT, it doesn't matter. So yes, it can. What data format does the software support? I mentioned it was NV data type number 12 or 4 BIL interleaves. Model is useful for satellite aerial imagery. Yes, I mean, sure, it could be used for that. You can make modeling. yeah, like every data, they need to be modeled, and here SpecimINSIGHT could be useful if you have those data, for example, in the right format. Are there any possibility of combining 2D spatial structure with spectral information in INSIGHT? No. In INSIGHT, you cannot really make data fusion, if it is what you mean. No, it is primarily only for hyperspectral data. So it doesn't have the possibility like this to make fusion. How is reflectance calculated in the software? So basically it is done line by line. So imagine you have the line which is acquired like this by the camera, and each pixels you have the spectral information. At the beginning or at the end of the data acquisition, you record what we call the white. So the white reference is acquired over a white reference tile, which is reflecting the light at 100% over the full spectral range. And you also acquire the dark reference. So when you want to do the normalization, you just take your raw data, you remove the dark, then you divide by the white where you have removed the dark. So you make the ratio, what is reflected compared to what is incoming. So basically, for each wavelength, you get a percentage what is reflected. Is it possible to check vis and near with single camera? I mean, check from 300 to 1700 for in-gas sensor. Well, first, with 300, you start in the UV. You are not in the visible anymore. Then you will have issue in finding, first of all, a good detector, which is having a good quantum efficiency at the beginning, from the beginning to the end of the spectral range. This is a bit tricky, and typically the in-gas sensors are not really good in the visible part. Someone could say I could use a CMOS one, and then it's not really sensitive as well, neither in the NIR part. So the difficulty is first to find a detector which is sensitive over everything. And then optically speaking, it's not so easy to have a single detector, because then you need to have like second order, third order, which are replicating at the top of each other. So for example, inside the FX10, you already have an order blocking filter, because the signal between 400 and 500 nanometers actually replicate between 800 and 1000 nanometers. So you need to think about that as well. But having said that, many years ago, we started to have what we call the Phoenix, which is between 400 and 2500 nanometers. It has a single front objective, but then it has a beam splitter. The signal between 400 and 1000 was going toward a CMOS sensor, and the signal between 1000 and 2500 nanometers was going directly toward the MCT. And then we were able to merge the both spectral range together. So we had like this the Phoenix, but it was two detectors, not a single one. Is the actual versus prediction graph? What points are plotted from the data set? This is the average, that was the average value of the selection. Can you scroll through the hypercube with the software? Yes, you can. You can do that. How long would a typical user case to learn the software? To be honest, it's pretty fast. You don't need to be a genius. The user interface is pretty easy. I would say if you use it really, in one day you are able to do already quite a lot. I would say in 1 week you know how to make all the tricks and things like this. So that's really, really fast. What kind of model is it possible to train? Only a regression? No, you can make also like a sorting, like classification with a PLSDA. You can also make principal component analysis. I don't know if it's really a model, but you can make this type of analysis. You can make also like color modeling, for example, with LEB coordinate or these kind of things. You could as well have some calculators, different type of index, vegetation indexes, for example, NDVI, things like this. So with this software, you can do all these type of things already. For pigment identification, do I have to make my own database for reference? Yes. With the software, we do not provide any libraries of reference libraries. You will need to build the library by yourself, like this. what can you do about dead pixels? So that's another story here. It's more about the dead pixel. It is in the camera. So in the camera, you have like in some detector, for example, the MCT or the InGaAs, you may have over the time some pixels which are not behaving as it should be, not normally anymore, and they are what we call dead pixels. So already on the detector during the acquisition, when we have bad pixels or dead pixels, sometimes we just correct them. It means like if you have the detector like this, you have a bad pixel which is here. Typically, we take the neighbor one in the horizontal direction, a vertical direction, because it is a spectral direction. So this is how we do. Then if you still have some and you have them in your data, you can see some spikes like this in your data. To get rid of them, you could use Savitsky-Golay, for example, like smoothing windows to get rid of those spikes. So this is what you can use. Can SpecimINSIGHT be used with data from SpecimIQ? Yes, yes you can, but not the model, remember that. Can the model trained in SpecimINSIGHT be exporting and used with Python script code? As I say, the model with Insight, created with Insight, is actually based on a Python code, but I have to say I need to check with our software team how transparent it is for the user, like if they can open it or not. That I don't know. Can SpecimOne produce false color infrared image by substituting red channel with IR? Yeah, just read it again. Can SpecimOne produce false color infrared image by substituting a red channel with IR? So basically, with the SpecimOne, you can choose to have as an output either the classification or the regression value, or you could get directly the reflectance value if you want, so kind of false RGBs. And here you can allocate to the red, green, and the blue whatever wavelengths you want to have. So if you are using an FX17, then you just allocate whatever wavelengths within 900, 1700 for the RGB. The same with the FX10, between 400 and 1000 nanometers. So it's just a question of allocating the bands you want to see. What light do you recommend for the FX50? The FX50 is a thermal camera. So you need to use something else than for FX10 and FX17. Typically for FX10 and FX17, there are a lot of LEDs available. You could use as well halogen. But that's okay for those cameras. But when you go to the thermal range between 2.7 and 5.3 micrometers, you need to use what we call our thermal illumination, and it looks like an electrical barbecue, to be honest. So it's like an electrical rod made of steel, which is heated up at about 650 Celsius, if I recall well. And we have this type of illumination. We have it actually as Specim for like widths of about 60, 70 centimeters. But it cannot be based on halogen. It needs to be a thermal illumination. Want to know if the image calibration is done on the acquisition software or will be done with the SpecimINSIGHT? The calibration, you mean the image calibration, so the one you are using for reference to build your model. That's the way I understand the question. So you need to image some reference samples that you know really well, that you know the characteristics, then you open them in Insight, and then based on that you can build your model on those calibration image. So I think this is a question I understand here. Yes, it's not a question anymore. Okay. So thank you. I think I went through all the questions. No, there are still some, sorry. As the video was accelerated, how much time does it take to build the model you had with Cotton? Actually, what took most of the time, it was to make the selection, as you saw. So to do that with the Cotton, I don't remember the number, I had about 60 samples or 64. It took me maybe 10 minutes to make all the selection manually like this. But the model itself, well, I have a quite good laptop, but the model, it takes maybe 10 seconds once you have made the selection like this. Making the selection takes time. Putting the values as well took time because it was the two things which are accelerated. I would say about 10 minutes. But what takes most of the time is actually to make the data acquisition because each of the data sets, they were acquired every 4 minutes. So with the Cotton, only the data acquisition took me about 4 hours. but nothing to do with the software, I mean. Does the white and dark change often, depending on room temperature, depending on halogen heating, or others? I would say it mostly depends on the camera you are using. So let's take first the FX10, FX17. Typically, the illumination is either based on LED or halogens. So here, the white reference will measure two things. First, the incoming light. So if you have the light which is changing, you need to take it more often. You need to take your white reference again. Or then, it depends as well on the sensitivity of the camera. So if the camera sensitivity change with the heat, then of course, you may have to take it again. With the FX10 and with the FX17, those are not really sensitive. So unless you want to make really accurate measurement for color analysis, for example, that's another story. But I would say if you want to make sorting or typical application, I would say the white, you don't need to take it so often. Especially if you want to work online. That's not a big issue. The dark, for FX10, FX17, it is the same. So typically, once you have the camera in a stable state, you turn it on, for example, half an hour before, like you have your online processes, that's okay. It starts to be more tricky when you speak about thermal cameras, like thermal ranges. So for example, the FX50. And for like online application, we always recommend to have the FX50 within a temperature stabilized casing, so that actually the fluctuation of the temperature around the camera, like the ambient temperature, doesn't affect anymore the camera. Because remember, it's a thermal camera, so it could be affected, of course, by the ambient temperature. So if you put it in a temperature stabilized casing, this makes the things more robust, and then the dark and the white, they don't need to be taken so often. Where to find the public data? You need to contact us. What is the best camera for scanning eggs? FX10. Will this presentation be available for download? I think Harry mentioned that yes, the recording will be available with the presentation. And he's looking at me saying yes. Once we have made a model with desired MROI using INSIGHT, can that MROI be set on SpecimFX camera so it only acquires those spectral bands? So once you made a model with INSIGHT, with the MROI, the spectral range that you want to use, and then you want to use this one, for example, with a cube for real-time data analysis, yes, automatically it will configure the camera so that only those bands will be read and processed by the software. Yes, we are sharing. What camera do you recommend for scanning internal defect or external possible in roots? What light should I use? Well, I don't have a lot of experience in roots, but well, it could be potatoes. But if you mean roots, I would say everything you want to see internally, typically you need to see through the skin or things like this to have a better penetration depth. So I would go for IR, like FX17 or sphere camera, and then here you need to use halogens. Okay, that was the last question. No, sorry, still. What camera is recommended for pigment identification? If you want to do for color, I would say typically you will go for FX10. But for pigment, typically those were made out of different type of soil. So at the end, it almost turned out, you know, when you make pigment analysis to be geological analysis. And when you want to make geological analysis, it's better to use FX17 or sphere camera because you want to identify different type of material on which the pigments are based. So if you want to analyze only the color, like purely the color, then you need to use a color camera, so which the FX10 is good between 400 and 1000 nanometers. But if you really want to analyze the type of material which is used to make the pigment, then you may need to use the FX17 or the sphere camera. They can be both working at the same time as well, FX10, FX17, and the sphere. Is the image normalization done in the Specim INSIGHT or acquisition software such as Lumo? You can do both. So basically, INSIGHT can do it if it gets the raw data, the dark and the white, then it can compute the normalized data. With Lumo, you have the plugins, which is called reflectance, and then it can calculate as well the reflectance data. Is the image normalization done on the Specim? Yeah, it's what I was saying. Okay. Is there a way to increase the line rate, to 4,500 frames per second. Yes, so here the demo was with the FX17, which is between 900 and 1700 nanometers. And if you look at the full spectral range between those ones, with 224 bands, basically the maximum frame rate is about 600 frames per second. Of course, there is a camera link and the geeky version, but it's what we are talking about. But the good thing with the FX17 as well as with the FX10 camera is that you don't need to read the full spectral range. If you're interested, for example, only in the band between, I don't know, 1,000, 1,200, and then 1,600, 1,700 nanometers, you can select those bands. And then because you read less bands, then the camera can go faster. So as an extreme, to the best of my memory, for the FX17 with one band only, you can be up to 15,000 frames per second, if I recall well. And with the FX10, it's close to 10,000. So 4,500 frames per second, yes, this is something which is reachable without any problem. I work with the Specim IQ model. I have the Specim Studio software, so IQ Studio. I have to buy other software. Well, it depends what you want to do. But if you want to use this software, which is compatible with data acquired with IQ camera, then okay, you can purchase Insight. If you make a model with Insight based on IQ data, you can make your model, yes, as I said, but you cannot then load it as an application compatible with IQ. So you can process the data, but then you cannot convert into an app suitable for the camera. Can you use shape other than rectangle? Then here you are talking about making selections. So in the training, and also when you want to make selection for training your model, also evaluation, or when you want to make selection just to see the spectra, you have different possibilities. So you don't have to use a rectangle only. You have, if I recall, there is a freehand, there is the elliptical, there is a brush, and there is also what we call somehow the spectral angle mapper. So it's a magic one. You just click somewhere, and then everything looking quite similar will be considered as a selection. So it's really good if you want to make object selection, for example. How do you separate foreground from background when looking at the image? Do you do annotation for segmentation? To separate the background from the object, so basically you have like 2 ways to do. Either your background is super dark or it's super bright. As you saw, when you are making your model, you have the possibility to set a range of thresholds somehow. So it's looking at the average spectrum for each pixel. And if it is below a certain level, then it will be considered as the background. It could work also the other way. If it is super bright compared to the sample, you could say that everything which is higher than a certain threshold then will be considered as the background. If you cannot play with this kind of trick, then you have to create the background as a class, and then it becomes a class, simply. Can you make computer vision deep learning models using the software? If so, how do you select your training and test data? As the date of today, the 2 algorithms which are available with Insight, it is the PLSDA, the partial least square discriminant analysis, or the PLS regression. Those are the 2 algorithms available. We're not talking about deep learning, even though some people consider the PLSDA as a deep learning, but well, it's not the same, in my understanding. So at the date of today, we don't have these abilities. So no, you cannot do it for now. But be aware that in the roadmap of this software, we are planning to use more and more algorithms to do different kind of things. But at the date of today, no deep learning. Can you find the most important wavelengths? This is, I think it relates when you make the wavelength selections. When you build your model, as I say, with the FX camera, you don't need to read actually all the bands to build your model. So the point of that is that the camera can be faster, less data to process. So that means that it's easier for the cube as well to have a model which is fast, especially for online application, shorter latency. So you have 2 ways to check which are the most important wavelengths. Just by looking simply at your spectra. So you see the spectra that you want to sort. So you have the spectrum of A, you have the spectrum of B, and then you look at the spectra, and already by yourself, you can see where you have the most significant differences. But I agree with you, this is more like something which depends on the person, it's really subjective. If you want to have something which is more statistically oriented, you could use the PCA, for example, in the Explorer, and then you have the PCA loadings. So from there, you can see which bands are the most important to separate different types of materials. It would be more interesting if you had overlap between two types of plastics. Oh, sorry, I thought it was already interesting, but let's try to make it more interesting. So indeed, you can have two plastics overlapping like this. So remember that hyperspectral imaging is a surface measurement method. So basically, you will measure what you have at the top. So if you have two plastics recovering like this, obviously with this one will be the one which is going to be detected. Unless it is transparent, then you get a mixture. But that's true that overlapping or masking could be an issue. How we can use hyperspectral drill core with SpecimINSIGHT. You can use it the same way as you would use any other software. With Insight, we do not provide any spectral library, which is dedicated especially, for example, for the mineral, for geological application. So here, you will need first to build your own hyperspectral library, depending on the mineral you are looking at. So you have to first measure the pure samples, the pure minerals, then you extract the spectral signature, and then you are able then to make your model. This is the way to do, but we do not provide hyperspectral libraries. Would it be possible to run a curve fitting algorithm to spectral data at each pixel and output curve fit parameters at each pixel in real time using the cube? For example, if I wanted to fit each spectra as YAX2 plus B squared plus C, is it possible to output A, B, and C for each pixel? So what you ask here is that we do not output anymore a classification, but we then output a model. So it means that for each pixel, you will have a different model somehow. A curve could be assimilated to a model. No, this is not what we do. I understand your point, but this is not what we have designed the cube for. So no, this is not something we do. You use reflectance data in model development. Why use reflectance data for that instead of dark subtracted? How do you use the dark ref and white ref for normalization? I don't want to make a model based on dark ref only, because the point is you have to take into account the white reference. When you do the normalization, you take your data where you remove the dark. Okay, then it means data without noise. Then you divide by the white minus the dark ref. So that means that for each wavelength, you actually compute what is the light reflected compared to what is incoming. All right. So if I would base a model on dark reference or like dark removed data, it will not be robust or independent from the incoming light. When I base a model on reflectance data, it is independent on the incoming light. So I can use whatever halogen, LEDs, whatever illumination, the spectral reflectance will be always the same. So that's why it's better to use reflectance data to be able to be more robust and to be able to export your model to different type of environment. So reflectance, it is intrinsic, somehow like property of your material. Does the quantitative model use about 100 spectra average of each patch or each pixel individually? So you saw when I was making selection over the cotton patch, first you could visualize the average only below, but you could see also the mean, the max, and things like this. But as a default on the plot option, you get only the mean. But the model is built on each individual spectra of the selection. So it is actually the way it's working, not only on the mean, but each pixel which is selected as a related spectrum. Where can I find the data used in this demo? Contact us. Please contact us, info@specim.com. And here we will be happy, we'll be really happy to share some data with you to show you what can be done with the software, like the data I was showing about plastics. There were also some with almond. We are happy to share those. So no problem, contact us and we will come back to you. How long did it take to run the PLS model on the cotton data? Well, actually, what took most of the time was to make the selection, to input the values for each selection. So here, what you saw, it was a bit faster. And I would say it was about 10 to 15 minutes to do that. What took the longest time was actually to collect the data because every measurement was taken every 4 minutes. But with our acquisition software, Lumo Scanner, it's possible to have a plugin time lapse that you can program, let's say during 60 measurements every 4 minutes. That can be done automatically. But about 10 minutes. And then the model itself, pretty quick, less than 30 seconds. After creating a database, is it possible to identify a set of plastic of different size and that comes somewhat overlapping? And how accurate is the identification of black plastic after creating? I have to read it again. Is it possible to identify a set of plastic of different size? Okay. Basically, the size of your sample doesn't really affect the spectral signature. It's just a question, size of the sample compared to the size of your pixels. I'm used to say that a sample, to be nicely detected, you need to have at least bigger than 3 pixels. So if you have, for example, a pixel size on your conveyor belt, which is about 1 millimeter, I would say the smallest particles that can be nicely sorted, it is actually 3 millimeter. Why is that? Because if you take smaller than that, you will have a mixture always of your pixel, of your sample, and the conveyor belt. So you will have difficulty to extract only the pure spectral signature of your sample only. So this is a ratio which is safe, I like to tell to our customers. But it doesn't really matter if you made a model with big or small particles or things like this. It's just like what I was explaining about the fact, like the aspect ratio. Then you were asking about black plastic. Then it is another camera. It is with the FX50, which is between 2.7 and 5.3 micrometers. It is a thermal camera that we sell exactly for this application. It works really well to sort offline, but also online, like, for example, PP, PE, PS, ABS, PCABS, and if they are black and not black. So if they are not black, FX17 can do it. If they are black and also others, FX50 can do the job. Will this demo be available to view again on demand? Yes, basically, if you register to the webinar, you will get a link to the video. Why it makes noise when you do the selection or calculation? Well, it was just to make things faster. You know, when I was making the selection, Harry, who actually made the cut and the edition of the video, told me it was a click of my mouse, simply a clack, 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 clack. So quite a lot of click. And about the computer making the model, it was just to make things faster, not just to be like without any noise, but nothing else. Then, can this software used to classify pixel and transform data derived from airborne hyperspectral survey, just as SpecTIR? Basically, this software can read every data which is compatible with the format NV data type number 12 or 4 BIL integers. BIL interleaves, sorry, at the end of the day, I'm a bit tired. So yes, as soon as you have this type of data, then you can import it into the software. That's not a problem. Then you can run the same type of algorithm I was showing. You can make the PLSDA, you can make the PCA, you can treat your spectra independently for each pixel as you wish. The only thing that keep in mind is not software dedicated for airborne application as NV would be, for example, with georeferencing, different type of tool like atmospheric correction. This software doesn't have that. But if you have already reflectance data, then you can process them. And be aware that in the Explore view, I did not show it, but you have the possibility to have calculator. So for example, you can run indices like NDVI and things like this. And then you can get as an output NDVI like maps. Please do inform in using comometrics analysis. Okay, so here this software, it could be used for chemometrics, but it's not really like, I don't know exactly what you mean, like explaining which peaks correspond to what. Like, for example, the moisture was 1430 nanometers, things like this. It's more like a software which is used like for like, as I say, PLSDA. If you mean that it can relate to chemistry analysis, this software is not really suitable for that. If it is what you mean, I'm not sure here. Does the software allow the user to calculate band algebra to classify pixel? Example application, capture mineral indices from remote sensing or album datasets. You can, as I say, use different kind of formula. You can create those. There is an operator, which is actually in the Explore view. And there you can have different type of indices. You can add those indices by yourself. You can put the formula you want. So there is this possibility. And then you can run those on different type of data. Airborne, why not? How effective is this tech for applying linear and sphere imaging of marine sediment? Bon, I have seen different way of doing that. So first of all, if it is marine sediment, it means that those have been taken already. So it means like kind of drill core from the bottom of the sea or things like this. Those are typically really wet. So when they are wet, the water is acting somehow as a mask because it absorbs most of the wavelengths, especially in the NIR spectral range. So the most effective, I would say, it is a VNIR between 400 and 1000 nanometers. Having said that, if you have your sediment and you have managed to dry them, then the sphere or the NIR camera, the sphere is between 1000 and 2500 nanometers, and what I call FX17 between 900 and 1700 nanometers. Then those cameras can start to become efficient because the water doesn't act as a mask anymore. But those could be used that way. Can you show a dome on how to collect hyperspectral data? A dome, I'm not sure what is a dome, but how to collect hyperspectral imaging data. So basically you need to adjust your integration time. You need to adjust the focus. Once you have done those things, you can adjust the frame rate, the speed of the scanner. Demo. And oh yeah, and Harry was right. Maybe it's a demo, not a dome. Yeah, well, this is the way. How to arrange? I would say it's possible as well to do it online. So here I would say contact us again, info@spekim.fi or .com, and we will be happy to contact you, and then an online demo can be organized. Is SpecimINSIGHT free for the customer having Spekim IQ camera? No, you have to pay for it. Please inform to perform chemometry. That was the same question. Is SpecimINSIGHT free for that? The same question. Do you have example for complex mineral analysis from core or other geological process? I'm interested with real-time in edge computing. I don't have example just here, but at Spekim we have actually some application specialists who have been working quite a lot on geological application online, offline. So if you have some question like really you would like to address with them, to discuss with them about different like complexity for geological application, please drop up a message, and then again we can come back to you. But here SpecimINSIGHT could be used. I don't see why it would not be able to be used for geological application. I think the most important is actually to find and to use the right camera with the right spectral range. And for geological application, we have seen that the sphere camera is really useful, so between 1000 and 2500 nanometers. Then the long wave infrared between 8 and 12 micrometers, also the visible part. After purchasing the license, there will be no need to renew it every year. This is a commercial question. So here I will ask you to contact our sales team. And here as well, we have like maybe our competitor. I'm sure we have our competitor looking and listening to this webinar. So I'm not going to give any answer about the commercial aspect, but please contact our sales team and they will give you all the details. Is it possible to do arithmetic to calculate reflectance? Well, reflectance is calculated automatically already with the software. You input the raw data, the white and the dark, and the software can compute those already. But you can make arithmetic. As I say, there is a possibility in the Explore view to have a calculator, and then you can put the formula you wish with ratio, plus, minus, things like this without any problem. What is the largest sensor that you offer? Largest in terms of size or in terms of spectral range? Well, I will speak about in terms of spectral range. We have the Phoenix, which is between 400 and 2,500 nanometers. So this is the largest one we have in that respect. But in terms of large, it's not bigger than that. I mean, it's not like it's not few meters large. If I compare with some of the camera manufacturers, some of the sensor was like 1 meter long or things like this. This is not the case with the Phoenix. So this is the largest one we have, if it is what you mean. So we need SpecimCube for building the app, or Insight is enough. The cube is here to run the app in real time. If you just want to make the modeling and build the app just to build the app for the sake of knowing the app, but to build the model, you just need to have Insight. The cube is really here to run the app in real time. If you want to make offline data analysis, you don't need the cube. Can we use your software, but with IMEC camera we have? It depends on the data format, as I said. So if it is the same data format as we use, then it's possible. Otherwise, no. And there is a nomadic shape detection to detect a round or square shape. No, we don't have that yet. We don't have the object recognition, but it is part of our roadmap to have like this object recognition. I don't know exactly the schedule for that, but it is in the roadmap. Not yet. Can you connect SpecimCube to another hyperspectral camera? No, only Specim one. Or you mean, can you have two hyperspectral cameras at the same time? So we are also working to have the possibility in the future to have two FX camera connected to a single cube. But if you mean by another camera than Specim, no, if it is what you meant. I'm a student working on hyperspectral imaging research. Do you have any free data set available for students to use to learn about this area of research? Thank you. The data that I was showing here with the plastics and also the almond, we are used to provide them to our customer or potential customer to look at hyperspectral data. So yes, we could provide you with some data. That's not impossible. Please contact us again. info@specim.com. How can I perform HSI on alkaloid? Here, what comes to my mind is, for example, the tobacco industry. I know that hyperspectral imaging has been used on tobacco industry to detect different type of alkaloid, to detect the nicotine, to quantify it. This is what rings to me here. It is mostly with the sphere cameras, this type of analysis, so meaning between 1,000 and 2,500 nanometers, because you really want to see the chemical composition of your sample, and this is more within the sphere spectral range. We had customer doing with that. We had some playing as well with cannabis. It was more the THC content, might not be exactly the same. But again, it's always at the macro level. Like if you take the leaf and you look at the pixels, but it's not at the really detailed level, microscopic level. So this is what comes to my mind, but more to the sphere spectral range. Is it possible to access to information obtained by the model from an external app? In example, object dimension, object size. Well, typically what happens is like when people are using our Specim one, you have actioners after that. So basically there is a camera connected to the cube. And then the output of the cube, it is a line seen by the camera. And for each pixel, then you have a classification. Then after that, you can, for instance, output the cube as an input to, for example, a system from Beckhoff. It's one, or it could be like another one, which is Gigi compatible. But if I take the example of Beckhoff, then in their software TwinCat, they have the possibility to receive those lines and then to detect from those lines if there is an object or not, and things like this, and to find the gravity center of it, so that you can have, for example, PLCs afterwards to eject it. So the cube doesn't give you those objects, but what you have afterwards could be compatible with it. To calibrate front light and background light at the same time, do we have to split the front light as background light? So here, the front light and background light. Do you mean the light from the background, from the light of your sample, if it is what you mean? So if you have a sample which is highly transparent and you want to decorrelate somehow the signal of your sample compared to what you have as a background, then I would say you need to normalize maybe with your background instead of with a white reference. That could be one way to do, but is it exactly what you mean? I'm not sure. So here maybe you could post us an email after this webinar, and we will come back to you. Can I perform HSI on isomer compound? Why not? I don't see why it will not. So you will just look at, for example, the different type of mail, like, no, yeah, I don't see why it will not. Is there an online manual for INSIGHT? I'm trying to figure out how to combine several samples. I did not catch a specific step. Also, is it possible to export the wavelength data into a CSV file? There is a manual which is not online, but if you have purchased INSIGHT, then we can send you the manual, and then it explains how to combine your samples together. There was a function about the mosaicing. So basically, you go to the Explore view, you make some selection, you select them, you right-click, you can create a mosaic. This is the way to combine. And then once you have made some selection, again in the Explore view, I think you can do that in Train as well. You right-click on the selection, and then you can export the mean spectra as a CSV if you wish. Do you need any white panel for data calibration and to convert signal to reflectance? If yes, which white panel reflectance, 25, 50, 75, should be used as an example for dark rock? Yes, if you want to make some reflectance conversion, you need to have the white reference, because then it tells what is incoming light seen by the camera, by the way. Then, if you have a dark rock, you have two approaches, actually. You can choose to have a dark white reference, which is quite close, I mean, gray dark reference, gray white reference, sorry, which is close to your dark rock in terms of reflectance. The good thing with that is that you don't need to have a short integration time due to the white reference, and then this short integration time is not suitable with the rock. So here I will recommend you use one which is darker, 25, 50, 75%. It depends on the brightness or the darkness of your rock. Another approach is to use dual integration time. So here you have your white reference, which is captured with a certain integration time, which is short, and then you acquire the dark reference related to it. And then you use another integration time, much longer this time, for your rock, which are darker, and you also acquire the dark reference related to this integration time. And then you can make a dual integration time normalization. We have the formula for that. We have actually a technical note for that. It's just like it works really nicely as well. We use that as well for the black plastics. It's useful to apply pre-processing in PLS regression. Can it be done by INSIGHT? Any suggestion on which pre-processing is better in this case? Yes, you can apply some pre-processing to make the regression, and in INSIGHT you can select those pre-processors the same way as you saw it for the PLSDA. In that case, I have to say, like for the cotton pad, it was better without any pre-processing. But sometimes I know that pseudo-absorbance could be really useful. SNV transform could be also really useful. Then it depends on the application, basically. The white reference used to automatically calibrate the camera when scanning and not to calculate the reflectance. The white reference used to automatically calibrate the camera. Well, the camera actually is not really like calibrated with a white reference. So when you do that, do you mean radiometric calibration? So then the radiometric calibration is not done actually with a white reference. It's done with an integration sphere. So that's a different story. But I mean, for the camera itself, it doesn't need to have a white reference to be calibrated unless you want to do radiometric calibration. So that's a different story. Any algorithm exists in your software for band selection. So this is a little bit what we were explaining like before. Is there is a way to detect better which bands include the most information in your data set. So either you do it by looking, and you can look as well at the loading for the latent variable when you make the PLSDA model, or you make a PCA and you can look for each principal component, what is the loadings. So here again, you can look in a statistical way which band is the most important. It's not done automatically. I mean, like it's not automatically that it would tell you look at those bands, but by yourself, you can have access to this information. How we can use your software in our hyperspectral 3D core imaging and mirror-jogging data. Well, you can use it in a way that you can do the same as I was doing, for example, here with the plastics and with the cotton pad. You can build your own hyperspectral library or your minerals of reference. This is the way you can do. You can build the PLSDA the same way as here I was doing with the plastic, but with your minerals. So this is the way you can do. Do we able to fuse hyperspectral data with LiDAR data in this software? No. This software is not suitable for data fusion. This software is suitable really for hyperspectral data, but no fusion with other type of sensors. So for example, 3D profilers or things like this. So no. Is Specim one a line scanning or point scanning hyperspectral camera? It's a line scan. It's not working as Whisker. It's really a line scan device. Then each pixel of the line, they have independent hyperspectral information, but it's working in such a way that there is a front objective, behind there is a slit. Then you have only a line, I mean, the light entering the slit, and then we have the spectrograph, which is then, how can I say, dividing the light depending on the wavelengths on a 2D detector, but it is a line camera. It's not a point spectrometer. Can you provide the link to the tech note on dual integration time? Yeah, we can see that after. So I think Harry has your contact details, so we can come back to you after with that. Can you email me the FX15? It's 50. 50 FX15, 17 HSI camera technical specification and cost of post alongside software application which help in analysis. We need to perform chemometric of alkali component and also for isomer. All right, please contact us, info@specim.com, and then we will come back to you, or the sales team will come back to you with an offer. Okay, that was actually the last question. So thank you. Thank you for attending this webinar. It was a pleasure to be back with you. That was the first one of 2023. It was a little bit longer than planned, yeah, because we had a lot of good questions. Really, really nice to have you here. If you have any question, please do not hesitate to contact us, and then we will come back to you. So I wish you to have a nice day, a nice evening, and see you next time. Bye.